So any questions or issues from yesterday with introductory stuff, but also with getting your first programming assignment turned in? Yeah, I should probably set up separate entry codes for different classes, but that's okay. All right, so let's continue with Java. So I want to go ahead and make some classes. So I'm in a work area. We're still not going to worry too much about what all the weird stuff is that we write for a main program. We're just going to play with some Java code right now. So let me make a main program. And we're going to make our first object today. Our object is going to be a rectangle. Okay, so what is a rectangle, right? Advanced math here. So this is going to be a rectangle, and it's going to have a width, and it's going to have a height. All right, pretty straightforward. So I want to make a class called rectangle. Every class that we make, every structure that we create, every one of these composite things that contains data and code is going to be its own class. We're going to put it into its own file. Okay, so I want a class called rectangle. It's going to go in a file called rectangle.java. And the naming is absolutely critical, right? If I put it in a file with any other name and I try to compile it, it's going to complain that the file name isn't right. I also want to introduce a convention right up front before we start actually making classes and objects. Classes start with an uppercase letter. For example, Rect. Objects usually start with a lowercase. For example, my rectangle. So if I'm defining a class, always make the first letter of that class name uppercase. You don't have to make the whole thing uppercase unless you want to shout at someone, right? But the first letter should be uppercase. Now that's not part of the language itself, but it's an almost absolutely universal standard. And similarly, when you have a variable, an object that's a type of a class, usually it's going to start with a lowercase. You can mix case after that. You can do camel case like this, or if you like snake case, you could do this. Most people in Java do camel case, where you sort of uppercase the first letter of each word, other than the very first word, to make it easier to read. So those are conventions, but this one convention I am going to ask you to stick to. Class names start with an uppercase letter. Objects start with a lowercase letter. Okay, so let's make a class called rectangle. So I'm going to say, I'm going to keep saying public because everything that we're making we want to be available from outside this file that I'm writing in right now. We'll talk more about public, private, protected later on, but for now just use public, you're safe. So to define a class, optional keyword public to say everybody can look at this, and then the keyword class. Okay, that's like struct in C. That's saying I'm about to define a class, followed by the name of the class itself, which for us is just going to be Rect. Okay, so that's the name of the class we're defining, opening curly bracket, and then everything inside here is part of the class. So let's just make this a very simple class that just contains a height and a width. So I'll say this has a floating point value called a height, and probably a pretty silly comment, but just to get in the habit of making comments. tell us what the height and the width are. I'm going to put a note in here that these should not be 0 or negative, and we'll see why I'm doing that later. And yeah, I'm seeing a mega delay too, and I'm not sure why that is, but I'm logged in as an observer. And yeah, I'm seeing about a 30-second delay. Let me turn off my observation and see if that improves my network speed. Okay, I don't know if that's going to help or not, but my my upload bandwidth is a little limited here, so see if that helps. All right, so this is our whole rectangle class. It's basically just a class called rectangle. It has 2 elements or fields to it, height and width. Okay, 2 members, and that's it. So let's use this class, and let's make a rectangle. So rect is the name of the thing that I'm trying to create, and I'm going to call my rectangle R1, and R1 is a rectangle now. And let's set the height of R1 to be 10, and let's set the width to be 15. All right, if I try to compile this, I will get some glorious errors. So I try to compile main.java, and it gives me a really nice error. It says variable R1 might not have been initialized. Okay, this is very different from C. In C, if I defined a pointer and I don't give it an initial value and I try to use it, I just get a seg fault when I run. Java, the compiler is pretty smart about trying to keep you out of trouble like that. So I've defined R1 to be a rectangle. Internally, we might think of it as a reference to a chunk of memory that's going to hold a rectangle, but it hasn't been initialized yet. It's not actually pointing to anything in memory. And the compiler knows that. And it's saying, hey, you might not have initialized R1 yet. Okay, we need to allocate memory for it. In C, we do a malloc. In Java, we do something a little more palatable. We say R1 equals new rectangle, paren, paren, semicolon. So up there I'm saying this is an object of type rectangle. This one actually constructs a rectangle and names it R1. And then we can access some fields inside R1. So this code will compile. And when I compile main.java, it knows it also needs rectangle.java to be compiled, and so it compiled it for me. I never said compile rectangle.java. It did that on its own because it knows that I need a rectangle, and it found a rectangle.java. So that's kind of nice, right? That's a feature. All right, so I can run this, and it doesn't do anything, but it doesn't blow up either. So that's promising. All right, so I've made a rectangle, I've given it a height and a width. Not surprisingly, we can use those fields and do something like this. I can say, let's print out the area of R1, it's equal to, and I can say R1.height times R1.width, and that'll get appended to my string area of R1 equals, and that should tell me my rectangle has an area of 150. So I can compile, and I can run, and there's our output. right, so this looks, you know, a lot like what we've been doing with structures in C. And again, you can always do C inside Java, but we want to do Java with Java, right? We want to take advantage of the extra things that we can do in Java as opposed to just, you know, pretending we have structures and a non-object language. So let's make our rectangle class a little more interesting. We've got a height and we've got a width. Okay. Let's write a method, a function that gives us the area of the rectangle. Okay, so this is going to be public float area. And I'm going to return height times width. All right, let's stare at this for a minute. There's a lot going on right here. I'm defining a method, a function called area. It returns an argument of type float. It does not take any incoming arguments. Okay? In a non-object oriented language, we would say something like, you know, area parentheses, and we would pass the thing whose area we want. But in Java, this area method is part of the rectangle class. So if we construct a rectangle, that rectangle has a height, that rectangle has a width, that rectangle also has an area. Okay, it's kind of like just another field on this object. So over here, what I could do is, in my main program, I could say area of R1 is R1.area. Okay, so think about that. Area of R1 equals, and we can say R1.area. I'm going to call this main2. So I'll keep my code. So, well, I just blew it away. So R1 has a height, it has a width, it has an area, and when we call that area method, what will happen is this code will start to run. Okay, this code is going to look for height and width and multiply them. What height and width will it multiply? This height and this width, which are the height and width of whatever object I used to call area. In fact, R1.height and R1.width. Okay, so let me just run this. Okay, area of R1 is 150. That's fine. Let's make a second rectangle. Let's make R2 as another rectangle. And this one's going to be a 5 by 5. And let's print the area of R2 and just use R2.area. Oh, I messed up. All right, you got to declare your variables. Compile it and run it. And area of R1 is 150, area of R2 is 25. Okay, so we want to start thinking of these things as, you know, in this case, R2 is an actual rectangle. It has a height, it has a width, it has an area method. And this is a fundamentally different feel from what we do in something like C, where we would say, you know, print out area parentheses R1. Print out area parentheses R2. That's the model where we had, you know, functions and data, and we just kind of put them together however we wanted. Here, the function is part of the data. Okay, it comes with it. And we can extend this, you know, in all kinds of ways. So we can find the perimeter of a rectangle. and just say return 2 times the height plus 2 times the width. Yeah, I have big trucks going by my apartment sometimes. Alright, so there's a perimeter method, and we can print out the perimeter of these things. Alright, so we'll print out the area of R2 and we'll print out the perimeter of R2. Alright, nothing terribly surprising going on there, but something pretty powerful, right? So this is what object-oriented programming is about. Hold on, let me close my window because I don't know how long they're going to beep. Slightly better. Alright, everybody still with me? Let me turn off my share for a minute. Alright, still got a full house, good. Alright, so the next thing we can do is, in C, when we want to construct an object of a certain type, like a node of a linked list, we call malloc, we tell it how many bytes we need. We don't have to do that here, we just say new. But when we construct a new rectangle, we actually say new rectangle, parentheses, parentheses, right? Usually when you have a pair of parentheses after a name, it implies there's a function going on, right? So it turns out when we construct a new rectangle or a new object of any type, we can have code execute when that happens. So let's make what's called a constructor for our rectangle. So constructors are created with the name of the object. Okay, so we're going to say public rectangle. And I'm going to do something we don't really want to do normally, but I'm going to put a print message into our constructor. I'm just going to print out a message that says I'm constructing a rectangle. Okay, we wouldn't want to do this normally because every time somebody made an object, they'd get this annoying print message. But this is just for learning purposes. So let's see what this does. And I need to compile rectangle. So I got 2 messages saying I'm constructing a rectangle, right? Because there were 2 spots where I called this rect method. Okay, now I could pass something in here. Let's just pass a number as an integer. And let's say this takes an argument. And let's print out that argument in our annoying little print message. Right? And so when I construct my 2 rectangles, I can see the value of that argument. Okay, we don't normally want to print messages here, but we can take advantage of this mechanism to do something more useful. So let's make our rectangle constructor something that takes 2 arguments. Let's call them H and W. And let's use them to initialize the height and width of the rectangle. So now I can construct a rectangle by passing 2 arguments to it, and it will set the height and the width accordingly. So let's make our first rectangle 10 by 15, and let's make our second rectangle 5 by 5. And we don't need to do this stuff anymore. And so we're right back where we were, but with a much easier set of code for the user who wants to work with our rectangles. They construct a rectangle here and they give it dimensions while they're constructing it. Alright, so you can declare your variable. You can say R3 is a rectangle in the same line that you call the constructor if you like. So let's play with this. And here when I tried to construct R3, it tells me that I'm trying to construct something with no arguments, but the constructor that I have requires a pair of floats. So it's telling me I don't have a constructor of the type that's required. Well, we can modify that. Let's make a constructor with no arguments. And let's just by default make the height and width equal to 1 each. So now I have two constructors. I have a constructor that takes no arguments, which gives me a default tiny square. Or I have a constructor that takes a pair of arguments and gives me a rectangle with those dimensions. Right, so now I can compile and run. Well, I'm not doing anything with R3, but I could. I could print out information about R3. And now R3 has an area 1 and a perimeter of 4 because it's a 1 by 1. I can make as many constructors as I like. I could make another constructor for constructing a square. Let's say we want to construct a rectangle where the height and the width are the same. Well, I'll make a constructor called Rect that takes a single argument, which I'll just call side. And that makes a square. So now if I go back to main, I can make an R4. Let's make a rectangle S for square equals new rectangle. And let's just make this a 10 by 10. And let's examine what that is by using its area and perimeter methods. And not a terrible surprise here. S is a rectangle whose area is 10 and perimeter is 40. Alright, so there are a number of things going on here. We've got an object, right, of type rectangle. We've got fields we can work with. We're using methods that we're accessing kind of like we would access a field on a structure. But there's this business of constructors, okay? And we have constructors named Rect, the exact same name, but apparently three different constructors. One that takes a single argument, one that takes two arguments, and a third that takes no arguments. And when we wrote our function Rect, we wrote it 3 times. Now if we try to do this in C, we're going to get all kinds of compilers. It's going to say duplicate definition of function rect. Okay? In Java, we're allowed to have multiple functions with the same name. Okay, so this is a key concept. In Java, you can have more than one function with the same name. And so this is the concept of a signature. A signature is a combination of the function name, the number of arguments, and the types of arguments. So a function is no longer defined just by its name. It's also defined by how many arguments it takes and what the types of those arguments are. And if you have two functions with the same name and the same number of arguments, but even one of those arguments is a different type from the other, it's a different function. And when you call a function, Java looks at the type of arguments that you're passing to it, and it looks for a function with a matching signature. And if it finds it, that will be the function that gets called. So I could make another constructor which takes an integer argument, right? And the compiler will be perfectly happy with that. This constructor, this function, is different from this one. If I call my constructor with a float, it'll run this code. If I call it with an int, it'll run this code. Okay, so that's an important thing to keep in mind. We can have multiple functions with the same name, and this is really useful. Okay, it lets us do a lot of cleaner coding when it comes to managing more general inputs. All right, so we have a rectangle. Well, here's something else we can do with a rectangle, right? So when we construct a rectangle and we pass a height and a width, remember we said we don't want these things to be negative. So we could do something like this. Let's say that R1 is a negative 10 by 0 rectangle. Okay, I run that. R1, it tells me it has an area of negative 0 and a perimeter of negative 20. Okay, that's a pretty dysfunctional rectangle. And if I try to use that with other code, you know, I might blow something up. I would really like the user never to use negative or 0 arguments for the height and the width of a rectangle. And if the person who's using my rectangle class simply says something like, you know, r1.height equals negative 10 and r1.width equals 0, I can't really do anything about that, right? So here's what we can do. If they're constructing this rectangle with a constructor, right, I can put code in that constructor that checks to make sure that these arguments are appropriate. So in my rectangle constructor, I'm going to do the following. So if height is less than or equal to, if h is less than or equal to 0, set h equal to 1. And then here I'm going to say if w is less than or equal to 0, set w equal to 1. Just like C, these things are passed by value. So if I change w in here, it doesn't change w in whoever called me. Okay, but now I'm putting a special feature in here which says if I try to construct a rectangle with an inappropriate height, I'm just going to force the height to 1. And I'm going to do the same thing down here in my square constructor. Right, and I'll just arbitrarily say let's make this a 1 by 1. So let's compile that, and now my main code, right, if I try to make this negative 10 by 0 rectangle, something more reasonable should happen. Right, R1 ended up being just a 1 by 1, area is 1, perimeter is 4. All right, so constructors let us not only, you know, provide a convenience for the user to be able to specify initial values while they construct the object, but it also lets us put control over things that we want to check or have happen when that construction takes place. There's still the possibility, though, of a user doing this. They might say R1 height equals -10, R1 width equals 0. They've already constructed it, right? But if they just go in and they change the value of a field, well, you know, the value of the field is now -10 and 0. I'm back to this rectangle of area -0 and perimeter -20. Okay, so what do we do about that? This gets into another key idea of object-oriented design, something called information hiding. Okay. Inside our rectangle class, this height and this width, these are really internal to this class. I don't want an outside user interacting with these directly. What I want them to do is set the height and the width through the constructor. So I can say, let's make these things private. Okay, we'll make height and width private. And now when I try to compile my main program, I get an error message saying height has private access inside rectangle. It's not going to let me compile my Java code that's trying to modify the height and the width. So now I'm basically saving the user from themselves, right? I'm saying you don't have the ability to modify the height and the width directly. All right, so that's information hiding. It's one of the key concepts for object-oriented design. Being able to control users' access to internal structures in our object. And we talked about this when we discussed data structures in 222, when we discuss a linked list, for example. We never want the user to be able to interact with the sentinel directly, right? We could make the sentinel private, and the user would be unable to look at the data value in the sentinel or change the data value in the sentinel, which, you know, might interrupt our code in some way if they were able to do that. When we make a stack, we can make the stack pointer private so that the outside user cannot say if the stack pointer equals 0, do something special, right? So building this firewall between abstract data types and implementation of data types. The implementation can be as private as we like it to be, and we only expose the things that we want the user to use to interact with us. For example, the constructor and the area method and the perimeter method. All right, so that's the theme we're going to come back to again and again. Let's take that a little further. So we don't have access to the height and the width. But suppose we want to know what the dimensions of our rectangle are. So we want to say R1's height is and print out R1's height, and R1's width is and print out R1's width. Well, we can't compile that either because we've made height and width private. And we can't make them read-only. Okay, there's no such thing as, you know, public for reading, private for writing. We've marked them private. That's it. Anything outside the class does not have access to them. But we can do the next best thing. We can expose these things that we want the user to be able to read by writing more methods. So we're going to write a pair of methods here. These are called getters or accessors. Public float get height. And it's going to be a method that simply returns the height of the rectangle. And we'll write another one for width. And since these methods are public, an outside piece of code can call get height or get width, and this code is running inside the class, so it has access to these fields that are private, you know, to other entities. It can find the height and it can return it. So we can compile that. And now in our main class, instead of calling r1.height, we'll call getHeight. which is now a method, so we have to put our parentheses at the end. And we'll call getWidth. Right? And these are just methods calls. The methods are public, and those methods return the height and the width of the rectangle. So we can compile that. And we can run it, and it tells us R1's height is 1, width is 1. So those are called accessors or getters. If we want to modify values, we use what's called a mutate modifier or a mutexer or a setter. So setters and getters are usually what we call them. All right, so we got a lot of pieces of object-oriented stuff going on now. And this is starting to look fairly different from C as far as what's going on under the hood. Let me go ahead and make a pair of mutators also. So accessors and mutators are setters and getters. Okay, and when we set the height, we don't need to return a value, so I'm going to make the return value from this void. And now I can say set height. I can pass a float, and if it's less than or equal to 0, it'll change it to 1, and then it'll set the height equal to whatever argument I passed. And I can do the same thing for the width. And now I have a way to let the user modify the height and the width, but again, in a very controlled way. Right? So they don't simply come in and say set the height and set the width. They can instead do something like R2 dot, or let's pick on our square. Right, we had a square S which was 10 by 10. Let's change the width to 20. And then let's print out what the new dimensions of this modified square are. Right? And so S was originally an area of 100, perimeter of 40, and now we've modified it to be an area of 200 and a perimeter of 60. All right. So hopefully if there's questions, people are talking, because I don't see hand raising on my screen because I'm full screen right now. Yes, go ahead.
So you made a bunch of the Rect methods for different inputs.
Correct.
For stuff like that. Is there any way to fit that down into one function or something like that, instead of having just a bunch of methods that are all called Rect?
They're really different methods, so you really want them to be separate methods. I mean, in this case, it was kind of silly because, you know, they were all doing mostly the same thing, but you might want them to do fundamentally different things. Now, one thing you can do is inside my constructor here, I could have called the constructor that takes 2 floating point arguments and passed it, you know, 1, 1, and reused it like that. So you have options like that. But yeah, don't feel hesitant about having lots of functions or methods in Java classes. Okay? It's pretty common that you look at it and it looks like there's a lot of redundancy. That's actually kind of a good sign. Does that make sense?
Yeah.
I have a question as well, real quick.
Sure, go for it.
When you're passing an object of the same type as a parameter and you want to access the values of both, do you need to use the this keyword to access the instance variable of the current object or not?
Correct. I'm going to avoid going into that for a little bit though, but yes, if you're there, this refers to the one from the class itself.
I have another question.
Okay.
So at the beginning, you said that classes always should start with a capital.
Correct.
I noticed that whenever you do a string, that's a capital, but all other like typical variable types seem to be lowercase.
Ah, thank you. Yeah, so technically integer is a class, okay? There's a class named integer, and you know it holds an integer and it's got all these methods you can use with it and so on and so forth. If we lived in a purely object-oriented mindset, every time we wanted to say I equals 1, we would have to do something like this. We'd say integer I equals new integer parentheses 1. Okay, if we had to do that, nobody would use Java. So we have some special things which are called primitives, which let us just say int I equals 1. And there's a handful of primitives: int, float, double, char, boolean, and I think there's 2 more that I'm missing. And the compiler understands when we say int, we really mean an object of type uppercase integer. Okay, it's a convenience so that we don't have to do this, you know, full construction of an object in the usual formal way, and it basically lets it look a little more like C. So those are special things called primitives.
But could we do that?
Yeah, you can do this.
Like the whole integer I is equal to new integer.
Yeah, go ahead and play with it. Because there's some differences between an uppercase integer and a lowercase int, but they're mostly interchangeable. But write some code, play around with it, and see what you discover. And same thing for floats and doubles. All right, other questions, comments? So let's do one more thing here. What happens if we try to print R1? Okay, I'm just going to print out R1 equals, and then I'm going to concatenate R1 to it. And it turns out if I do that, that will compile just fine. And when I run it, it says R1 equals rect @4AA298B7, which is a little weird, right? But anytime that I try to concatenate an object to a string, the system has some way of turning this into a string. Now in this case, it turned it into this very peculiar looking string. Okay, but it is a string, and it allowed me to concatenate it and then print out its value with that print line statement. It did that because every object that you create has a built-in method called toString. toString takes no arguments and returns a string. But it turns out I can write my own toString. So I'm going to make this public string toString. And I'm just going to return haha. Okay, just by doing that, now when I try to print out R1, it says R1 equals haha. So there's a few things going on here. So I've overwritten the original toString. So there's a few things going on. There's a built-in toString method inside every object, but you can modify it. You can write your own version of it. This is called overwriting. I've written my own toString, and now when I try to call that implicitly by appending R1 to a string, it calls this function. It gets the value haha. That's the value that gets appended to R1 equals. So if I wanted to be a little more reasonable than just saying haha, I could say return the following string, a rectangle of width, width, and height, height. And now when I run this and I try to print R1, and all I'm doing is saying, you know, print R1 equals, and I'm concatenating R1. Now when I do that, it says R1 equals a rectangle of width 1 and height 1. Really powerful feature right there, right? It lets us say, as we create our objects, if somebody tries to print this object, what should they see? And we can do whatever we want in here. We can return haha, we can return a reasonable string, we can run a bunch of code and do a bunch of things and do something based on the result of some complex calculation. It's totally up to you. All right, go ahead. We got 2 raised hands.
Dingus can go first.
Go for it.
I didn't ask anything.
Oh, you have a hand raised.
All right, go for it, Travis.
So I remember yesterday we talked a little bit about extending.
Mm-hmm.
Can someone then extend, like write their own method that extends toString, and they could write whatever they want it to look like?
They could extend the rectangle class. So you could make a Travis rectangle that extends rectangle, and in that definition you could write your own toString, and it would have all the stuff that's already in this rectangle class, but it would have your toString method instead. That's exactly what you want to do with extensions, yes.
Cool.
Yeah. All right, so that's the end of our time for today, but we've hit on about 18 billion really key concepts from objects. A lot going on in there. I'll put this code up on the server, and we'll play around with it more tomorrow, and we'll start looking at programming assignment 1 and how all of this relates to it. But you've basically got the mechanics for doing PA1 at this point. All right, was that an actual hand raise?
Yeah.
Cool.
What happened? Put an argument in the toString method.
Then it's no longer the same toString method. So if I, that's a really good question. So if I define a toString method that takes an integer I, well, when I try to concatenate R1 to a string, it calls the toString method that has no arguments. That's the default one. Right? The toString that I defined is just another function that happens to have the same name, but a different signature, right? Because of different argument types. All right, cool. Have a good rest of the day. I will see you all next time.